Ed has created a class of presets called drones, which are basically look more no hands kind of presets where you don't touch the fingerboard at all to get a sound. So the implication here is that there's not much use of X, Y, and Z based formulas in the presets. In fact, they're mostly composed of shape generator based control and constants. So let's take a look at some of these and you'll see what I mean. They're intended to start the minute you bring them up. And here's one called Countdown. On this one, let's just take a look at some of the formulas. You see there's a lot of constants in here, a lot of shape generators, and here we have a formula: shape generator, shape generator, shape generator control, shape generator control, shape generator, shape generator, shape generator, shape generator. So all of the formulas in this are derived in some way based on shape generators, and the other elements in here are constants that do various things. Why so many constants? Well, there's no X, Y, and Z formulas to deal with, and these presets are meant to come up and play a repetitive drone-like sound that just kind of iterates. Changes sometimes in some nice ways, but it's still basically iterative based on shape generators. Let's take a look at another one. Hal's Dreams. This one's a very simple one we'll take a look at in detail. Formula based on the shape generator, shape generator, shape generator, shape generator, and all the other values are constants. All right. Roller. Here's another one. Not too complicated, but we've got shape generators on C, shape generator there, shape generator, shape generator, shape generator. Rosetta alarm. Shape generator based, shape generator based. Okay. More shape generators. You can see this pattern is developing in all of these presets. Shape generators are what's driving the show. Right? And shape generators, I might add, if you notice, we look over here, where the trigger of the shape generator is typically set to a constant. That means these things are going to trigger the second they come up in the matrix. Couple more. Throat bottle, one of my favorites. Again, full of constants and formulas that are driven by shape generators. And the last one, same kind of deal. This one, again, based on shape generators. This one's a little different because it has one value here that's based on a constant. But other than that, as you see, they're very similar in design, and we'll take a look at one in more detail. Let's take a look at one of the simpler drones, Hal's Dreams. We'll bring this up, put the volume down, and maybe we'll put a volume multiplier on here that we can turn it off for now. Okay, what's this doing? You can see we have two oscillators. Oscillator 1, a little bit of that is being sent out the outputs. We'll talk about why in a second. Oscillator 2, nothing's being sent out the main outputs, but both oscillator 1 and oscillator 2, if we go over, we can see are being sent into a sum delay at 400 milliseconds. In addition, this delay, bank C, we look at that, is being fed back into itself to create this looped delay. And that, quite frankly, is the overriding characteristic of this preset. Now you'll also see that there are 4 taps that are sent out the stereo field. The tap is defined in the delay. This is just a percentage of the delay that can be specified in these T1, T2, T3, and T4 fields that Ed sets to the first being everything, then half of that again, and then half of that again. The shape generator itself that's driving everything, there's only one of them, is set to 2 times a second, and it's set to this one, which means it's going to trigger the split second this preset starts. The only other thing in the preset is there are some frequency constants that are applied to these oscillators. Now a value of 0.44, remember in the matrix, frequency constants are normally in kilohertz, so this 0.44 is really 440 hertz. Our standard A equals 440 in equal temperament tuning. Let's start by digging into the details of these two formulas, A and D. These are what are driving the pitch content of this preset. If you notice, they're both set up to be driven by shape generator 1, but they are set to the shape generator type of sample and hold. Sample and hold of the matrix row they're on. Normally, this is used on the noise row. What we want this to do is generate a random number, and that number is then going to be used as a base pitch that's going to be added to our 440 hertz to get the pitch that's going to come out. Sample and hold is also, in this case, not totally random because Ed quantizes it here on formula C. And if we go to C, we'll see that the sample and hold is really going to be output to the closest 0.5 that the maximum range supports. The range of this is going to go from -2 to +2 because the sample and hold values are bipolar in this case. Now, as it turns out, when things are quantized like this, it really rounds, so this is really only going to output 7 values in some random order from -1.5 to -1 to 0.5 to 0 to 0.5 to 1 to 1.5, but not in that order. They'll come in some random order. You might have 1 or 2 or even 3 of the same value in a row because there's no telling how the randomness is going to generate. One of the overriding factors here, however, is that when this value comes out to 0, it's going to add to the 440 and you're going to get those A's popping out. Outside of that, these values are going to be off the equal temperament grid. So let's turn up the volume a little bit. First, let's listen to the sound as is. You can hear it's kind of bell-like and very reverberant because of the delay feeding back on itself. But let's look at this formula now and turn on the display for that formula. I have to press the fingerboard for you to see this, but you can see those values now at the bottom left-hand corner are changing, and they're all coming out. They're 1s, -0.5, 1, 0.50, 1, 0.51, a random collection of those 7 values that I told you about. Those are going to be added to the 440, as we said, and a tone is going to come out. And let's, for the sake of argument right now, take away the delay and just listen to the oscillator 1 output, because oscillator 2 is not being output right now. You can hear, without the delay, it's not much. Now, you'll hear at sometimes it doesn't sound like values are changing twice a second. That's because the random order sometimes has the same value coming in a row. Taking a look at the second formula now, that's very much like the first, but it's changed a little bit. This one has, again, a value of 2, like the first, as the overall range, but the quantization is set to 0.66 and not to 0.5. So when I look at the values coming out of that, you'll see they're ranging on that 0.66 boundary. And when I take that into consideration with the overall range of -2 to +2, there are a few less values that can be output now. Let's listen to those in combination with the first 2 sets. I'll turn them all on now. Now we can hear we have a group of tones there. Because they're all being generated on the same shape generator, they're all coming out at the same time. What happens, however, if we take that quantization off? Let's not quantize. Let's just multiply times 1, which is our standard formula. We'll do that in both cases. Now let's see what that sounds like. There's no quantization. This could be any pitch coming out now in that range. Let's turn on our delay and see what that sounds like. It's actually quite nice. Only it doesn't have that nice simple pitch set that the original has. Now the other thing we can look at are these two formulas that are driving the input to the sum delay. B is using another shape. This is using this Han Unipolar Generator that gives you a sine-like motion from 0 up to max and down again. So this is basically saying I'm going to send 0.2 of the total output of this oscillator into the sum delay, and it's going to oscillate between a low point and a high point as it's being fed in. This is going to change the amplitude slightly and give you an even greater shimmering effect. F does a similar thing, only F uses a max of 0.1, not 0.2. You know what we could do? We could set this to 0.2 and set this to 0.1 and listen to what would happen without that changing amplitude. It's okay, but it's lacking something. Let's put back our formulas and try again. It's got a much smoother, nicer flow to it. But now let's do something that will totally destroy our sound and remove the looping input to the sum delay. It loses everything now, even at 400 milliseconds. The whole point of this preset is this recursive looping on itself. Let's do one final thing. Let's take away this little bit of output of the oscillator. I'll do it when the preset is in motion so you can hear what happens. Can you hear that? The little articulations that come in on each note have disappeared. That's what this little bit of motion of the direct oscillator to the output is doing for us, and it really adds something to the sound. There, the minute I turn them on, you can hear that little attack. Makes all the difference in this sound. There you have it. I think we've covered everything in this preset, and it can form the basis of something we can easily add to. You can see there's a lot of extra space in here. We have a lot of free oscillators. I can double up. I can do a lot of other things. Maybe I can change around the frequency content of what's going on here. And that's what we'll do in the next video.